And hello, 102 students. Got another question. Glad to see that you guys are working hard on this material. It has to do with number 16, and it looks like 16 has to do with a pressure here. Let me run through this. It says the pressure in each of your car tires, so pressure equals 2.5 times 10 to the 5th pascals, which, remember, a pascal is a Newton per square meter. Okay, the mass of your car is 1,600 kilograms. Assume that each of your tire bears 1/4 of the total load or the total weight of the car. What is the contact area? Okay, so maybe a good physical picture might come into play. I'll maybe do a little cross section of a car, and although I guess that will only give me 2 tires. But the tires are kind of flattened a little bit on the ground. And it's sometimes easy to forget that, we think, oh, the car is being held up by the tires. But really, it's the air in the tires. There's little atoms over here that are pushing on the ground and ricocheting on the rim. And so maybe the first thing to do is to go back a couple of chapters and do a free body diagram. Let me not draw the whole car. I'll just kind of make a little circle for the car. But I would say the car is being pushed down by its weight, which we learned was mg. And that goes way back to chapter 3. And then, of course, what's lifting up on the car is, I would say, the force from and I'll just put AP, from the air pressure. It is the force from the molecules in the tire. You probably know, without even taking a physics class, that the car falls down without air pressure in the tires. So you need some air pressure. It's the air pressure that's holding it up. And so if the car is just going to be, sitting in a parking lot or something, we know that the net force then which is ma, is equal to 0. So again, here's Newton's second law, and that takes us way back to chapter 4. But of course, the net force would be the air pressure pushing us up. The weight is pushing us down, giving us a net force of 0. And something that, I don't know if this was so obvious or not. I got a couple questions on it, so I thought I better work through it. But what this is saying here is that you need enough air pressure, or force from the air pressure, in order to lift up the weight of the car. So the force coming from the air pressure is equal to the weight of the car. Now we can use the new stuff for this chapter, which says this, that the definition of pressure is force divided by area. So if we move it to the other side, we have area times pressure is equal to force. And that's then what I'm going to put right here. So I'm going to say the area times the pressure is then equal to the weight of the car. Now, the car has 4 tires. I'm glad they tell us, because I suppose not all cars have 4 tires. But it says assume each tire bears 1/4 of the weight. So maybe I ought to do this. Maybe I ought to do my area and go 4A. And what I mean by A then here in this equation is the area of 1 tire. So like up here, when I said area, I really meant everything that was holding up the car. So this is the area of all 4 tires. And by the time you take the area of all 4 tires and the pressure, assuming the pressure in each tire is the same, so maybe I should say I have this term 4 times, I get mg. But if we're willing to say the tires are equal, that's what is kind of assumed in the problem. They said assume it's kind of equal, so the same pressure, same area, holding up the same amount of weight of the car. That's not always so true. A lot of times the front tires are holding up more weight because that's where the engine is. And even in the transmission. But Assuming that they are all equal, I'm just going to take, this is the area of all 4 tires, and I'm just going to call it 4A, where now this is the area of just 1 tire. So maybe I'll put a little A naught just to distinguish it from that A. Because it says, what is the contact area of each tire? So I want this number right there, 1 tire by itself. Okay, so now it's just a matter of plug and chug to finish this off. I have the 4, I have the area of 1 tire. I have the pressure, which was the 2.5 times 10 to the 5 pascals. And let me just remind you that a pascal is in units of newtons and meters. So let's make the other side, make sure it is in newtons. And of course, well, just newtons, so the newtons would cancel and I'll get area in square meters. But the mass of the whole car is the 1,600 kilograms, and the G is the 9.8 meters per second. So, again, buried in this Pascal is this Newton, which is going to cancel with that Newton, and I'm going to be left with just units of meters per second. So, I mean, meters squared, sorry. And so if I grab my calculator here, and then over here on the right-hand side, I go 1,600 times 9.8. Okay, so there's the weight of the car in newtons. Divide it first by 4, so it'll be the weight per tire, and then divide it by 2.5 times 10 to the 5th. This is going to give me my area of 1 tire. It looks like I got a 0.015, and I'll just round it to a 7 in square meters. Wondering if I should do square centimeters. Why not? Remembering then that there are 100 centimeters in a meter, and so if I square that, the square meters will cancel off, and I will have square centimeters. So 1, 2, 3, 4 make this 157 square centimeters. All right, hope that helped.